Day 2, Problem 1. Identify the slope and y-intercept for the graph of this linear equation. So let's do the slope first. Slope is also called rate of change. We need to find how the value of y is changing when the value of x is changed. And we can do that by finding some values for x and y. So as one value to try, let's put in 0 for x. Then y will equal negative 1/4 times 0, which is 0, plus 3, 3. So when x is 0, y is 3. Let's find another pair of values by changing the value of x to a 1. Negative 1/4 times 1 is negative 1/4. And now we want to add 3. So we need to find what negative 1/4 add 3 makes. Well, this whole number 3 could be thought of as 12/4. That gives a common denominator with this. And then 12/4 subtract 1/4 is 11/4. And then this can be changed to a mixed number. 4 divides into 11 2 times with a remainder of 3. 2 and 3/4. It was probably possible to figure out that negative 1/4 add 3 makes 2 and 3/4 to begin with. Here is the value of y when x is 0, and here is the value of y when x is 1. So let's look at the changes that have taken place. When the x has increased by 1 unit, look what happened to y. It changed from 3 to 2 and 3/4. It has decreased by 1/4, and that could be written as a rate. The y value decreased by 1/4 when the x value increased by 1. And this reduces to just negative 1/4. So there's our slope. Now it's interesting, when the equation is written in the form that it is, where the variable y is alone to the left of the equals, and then after the equals is the x term, and then after the x term there is a constant number added on, we can actually see a negative 1/4 in the equation to begin with. And so our answer we got for the slope actually appears as one of the numbers within that original equation. That's an interesting observation that we can use in the future. Now we're also asked to find the y-intercept. To find the y-intercept of any equation, we can substitute 0 in place of x. Well, we've already done that. When we filled in a 0 for x and worked out an answer for y, we got the answer 3. Now it's interesting, in this equation, in the form that it's in, where the letter y is alone, and then there is an x term, and then there is a constant on the end, we actually see a 3. So one of these numbers in the original equation actually is the y-intercept. Again, if we remember that in future problems, we could save all of this work here and just be able to figure out the slope and the y-intercept from numbers that are already in the original equation. Now part B, let's graph the equation. Start with the y-intercept. The y-intercept is at positive 3 on the y-axis. So here's the origin, 1, 2, 3. Here is positive 3 on the y-axis. Now we're going to use the slope to find a dot on our line. Here's the slope, negative 1/4. Or in terms of its rate of change, the y value will decrease 1/4 of a unit when the x value increases by 1 unit. So let's use that to find more dots. Let's increase the x by 1 spot to the right, and decrease the y by 1/4 of a unit. So I'm not going to go down 1 full unit, and I'm not even going to go down halfway to the next mark. That would be a half. we want to decrease by 1/4. So a tiny bit down, there's another dot. Now we can repeat this. When the x value increases by 1 unit, so I've moved my pencil 1 unit to the right, the y value decreases 1/4. So a little bit more down. Now I'm exactly halfway between this grid mark and this grid mark. We can repeat this. Increase x by 1 and go down 1/4. So about right here. And we could do this again. Increase x by 1 and go down 1/4. Finally, I'm to that next grid line, because if we go down 1/4 and 1/4 and 1/4 and 1/4, in total that would be 4/4, which is equivalent to 1 full unit down. And once we have all these dots, we can draw a line through the dots. Now day 2, problem 2. The table shows a person's weight during a dieting program. Assume the relationship between the quantities is linear. Find and interpret the rate of change and the initial value. In the first column, we have months, and in the second column, the person's weight. And we're asked to find the rate of change. Or how quickly is the person's weight changing. We can do this by looking at the rows in the table, and any rows are fine, but we might look at the first and second row. So from 0 to 2, 2 months has gone by. And in that 2 months, the person's weight has decreased, so negative 4 pounds. And we can write these changes as a rate. That's what rate of change is. So rate of change, see, the y value has changed by negative 4 pounds when the x value changed by 2 months. And this simplifies. Negative 4 divided by 2 is just negative 2 pounds in 1 month. And another way to write that is negative 2 pounds per month. That is the rate of change. How quickly the person is losing weight because they're on the dieting program. Now we're asked for the initial value. What was the person's weight to begin with before they started the dieting program? That would be like finding what's the value of y when x is 0. And there's actually a 0 in the table. So whatever the value of y is when x is 0, that is the initial value. That's 185 pounds. So we have the rate of change, and we have the person's initial weight.